So in order to talk coherently about systems of differential equations, we're going to want a way of representing all of the information that we find in these systems. And a really good object for doing that are these things called matrices. Matrices, that word is the plural of the word matrix. And what we're going to do is associate a matrix to a linear system of differential equations. So what we're really doing here is we're taking a little detour from differential equations into the world of linear algebra. Linear algebra is a field of mathematics unto itself, and it's very, very, very important for your life. I mean, it cannot be underestimated how powerful linear algebra is, particularly in this day and age, in the 21st century. People have gone so far to even call linear algebra the calculus of the 21st century. And maybe we'll have occasion to discuss that. But let's get started just by talking and saying some words, describing some ways of communicating or talking about matrices. So first of all, what is a matrix? It's just a rectangular array of numbers. It's very simple, okay? Nothing too fancy. So we're talking about matrices here. And let me write out for you a matrix which we'll call A. This matrix A I will take to have maybe 3 rows and 4 columns. So I'm going to draw, I'm going to write out a 3 by 4 matrix. So the first entry I'll write as A sub 1, 1, A sub 1, 2, A sub 1, 3, A sub 1, 4, A sub 2, 1, A sub 2, 2, A sub 2, 3, A sub 2, 4, and then A sub 3, 1, A sub 3, 2, A sub 3, 3, A sub 3, 4. This is what's called a 3 by 4 matrix. It's got 3 rows. Can you see them? 1, 2, 3 rows. And it's got 4 columns. 1, 2, 3, 4. So that when I talk about the third column, I'm talking about this column. And when I talk about the second row, I'm talking about that row there. Okay? So this is a 3 by 4 matrix. And whenever people refer to, and this is universal, whenever people refer to the dimensions of a matrix, they mean something like this. And this first number always refers to the number of rows, and this second number always refers to the number of columns. Okay. If a matrix has the same number of rows as columns, we call that a square matrix. So if the number of rows is equal to the number of columns, then we say the matrix is square. Okay, for obvious, I hope, reasons. It will be shaped like a square. Yeah. I don't know what else to say. Oh, maybe I'll say one more thing. N by 1 vectors, so n by 1 matrices, which have n entries and have n rows, 1 column, are called column vectors. Very useful. We think of them as being vectors. And things of the form 1 by m, these are called row vectors. Maybe for obvious reasons. They look like just a single column or a single row. Okay? Good. We also call these numbers here, we call these things elements or entries. Just throwing some more terminology out at you. Okay? Great. Now let's talk a little bit about some basic matrix arithmetic. So matrix arithmetic. So for example, if we have a matrix, let me just do this via example. Let's say that we have a matrix. Let's take an example of a 3 by 2 matrix. So maybe I'll just have this be 1, 2, 3, 4, 5, 6. And let's call this matrix here A. Okay? Then, of course, what I can do is I can multiply A, this matrix, by some number. For example, I could multiply it by -3. And what this means is I'm going to multiply every entry of A by -3. So I get -2, -6, -9, -12, -15, and -18. Hopefully that's clear. Okay. So if that's my A, then that's -3A. Note also that I could take this matrix A. I could take another matrix with the same dimensions. Let's call that matrix, I don't know, B. Suppose I have another matrix B whose entries are 0, 2, 4, 6, 8, 10. And I could add these two matrices together. And crucially, I can do that. I'm allowed to do that because they're the same dimensions. They have the same number of rows as columns. So it makes sense to add them together. And if I do that, if I do A plus B, then I get exactly what you would expect, I think, just the entry by entry sum. So I have 1 plus 0 here, which is 1, 2 plus 2 here, which is 4, 3 plus 4, which is 7, 4 plus 6, which is 10, 5 plus 8, which is 13, and then 6 plus 10, which is 16. And what I end up with is another 3 by 2 matrix, okay? But importantly, crucially, matrix addition A plus B only makes sense if A and B have the same dimension. So for example, if I was to try to add this matrix here to this matrix here, because there is a mismatch in the dimensions, this one's 3 by 4, whereas this one's 3 by 2, because of that mismatch, I can't add these things together. Okay? All right. So that's matrix addition. It's very, very simple. There's lots of interesting rules, I suppose, but I won't even sort of mention them. But one operation that I want to mention is called transpose. Okay, so definition. There's an operation called the transpose of a matrix. So if A is a, let's say, M by N matrix. So remember, this means M rows and N columns. Then A transpose is the matrix. Let me specify the dimensions. The N by M matrix obtained by swapping the rows and the columns. So what on earth am I saying here? So let me just give you an example of what I mean here. So let's say that we have a matrix A, which looks like 2, 1, 4, 2, 6, 6. Okay. Then so this is a 3 by 2 matrix. Please observe. This is 3 by 2 matrix. Then A transpose, which I'll denote like this. Sometimes the T is a capital T. I don't know why. For some reason, I have a lowercase t here. A transpose is the matrix where each row of A becomes a column of A transpose. So this first row will end up being 2, 1, the first column of A transpose. Similarly, the second column will be 4, 2, and this last column will be 6, 6. Okay? And please observe, this is 2 by 3. In other words, we've swapped the number of rows and columns with one another. All right? That's matrix arithmetic. And you can check that if you take a sum of two matrices, okay, and then you transpose that sum, that this is exactly the sum of the transposes. So it does what you want it to do. Okay? That's enough for this video. In the next video, what we're going to learn is something called matrix multiplication, which is an interesting and deeply important gadget in and of itself. Okay, so let's do that in the next one.